Okay, so here we will discuss about code converter. Now, what is code converter? Code converter is nothing but a circuit. Code converter is nothing but a circuit which is used to convert one code into another. Okay, suppose here I am taking a block diagram in which n represent the input code and this m represent the output code. So this code converter is used to convert one form of code into another. Okay. So here in this lecture we will discuss about BCD binary binary to BCD code converter. Here we will discuss about binary to BCD code converter. Before starting this conversion, first we understand what is binary and what is BCD. Suppose 2 is a number, so its binary representation can be 1 0 and its BCD representation is 0 0 1 0. It means that any number can be represented in, if any number is represented into 4-bit binary, then it is known as its BCD conversion. Okay, suppose I am taking 3. 3 can be written as 1 1 or it can also be written as 0 0 1 1. Okay, so here the representation of 3 in BCD is 0 0 1. Okay, if the number is 10, so its binary representation will be 1 0 1 0. But when we are dealing with the BCD, so its BCD representation, for finding its BCD representation, first we will represent this 1 into 4 bits. It means that 0 0 0 1, and this 0 into 4 bits, that means 0 0 0 0. So the BCD representation of this 10 will be 0 0 0 1 0 0 0 0. We can also write this number as 1 0 0 0 0, because we can eliminate these 0, we can eliminate this front bits, but we can't eliminate the lower bits because the weight of the binary code is started from 2 raised to power 0. Okay, so we can't neglect the below mentioned bit, but we can neglect the 0 if it is available in the MSB side. Okay, the binary representation of 11 will be 1 0 1 1. Okay, but but if I want to represent the BCD of 11, so what will be the BCD of 11? 0 0 0 1. This one is the representation of first one. Okay, now second one is represented by 0 0 0 1. Okay, now we can eliminate this first three zeros. So what is the final representation of 11? The final representation of 11 will be 1 0 0 0 1. Okay, it means that when we are starting the conversion, so till 0 to 9 the binary and BCD are same, but after 10 it means that 10 11 12 13 14 15 the binary and BCD will differs. Okay, to start this conversion, first we need to draw a truth table. First, we need to draw a truth table. Truth table is nothing but a table in which we find various outputs on the basis of different input combinations. Okay, so here I am making a truth table. Okay, this one is the truth table. This one is the truth table that represent binary to BCD conversion. Here in this table, here in this table, you can see these three bits B3, these four bits B3, B2, B1 and B0. Wait a while. Okay. Okay. Here you can see this B3, B2, B1 and B0. These are the binary input bits, and accordingly we will find out output in terms of BCD. So we have to take D0, D1, D2, D3. These are the binary, these are the BCD code. Okay. So when we represent the binary representation of 0, so we will write 0 0 0 0. And when I want to represent the BCD representation of 0, so it will be 0 0 0 0. Okay, so below mentioned bit, that means these are these bits. This one is the BCD representation, this one is the BCD representation of these 0. So till 0 to 9, till 0 to 9, it means that from this side to this side, from 0 to 9, the binary and BCD are same. This one is the binary representation, this one is the binary representation of 9, and this one is the BCD representation of 9. Till 0 to 9, the binary and BCD are same, but when we are taking the next bit, that is 10, so at that time the binary representation of 10 will be 1010. But when I want to represent this 10 into BCD, so we need an extra bit. That's why I have made one extra column D4 to convert this 10 to 15 number into BCD. Okay, so that's why to represent 10 we need an extra bit, so we will write 1 here and then 0 0 0 0. To represent 11 we write 1 here, then 0 0 0 1, same as 12, 13, 14 and for 15 also. Okay, so by after making the truth table, we will find out the various equations for outputs. Suppose I am finding the equation. Wait. Okay, suppose I want to represent the equation for D3. I want to represent the equation of D3. So what will be the equation for D3? To find out the equation, we check the D3 column and check where 1 is coming. So this one is the 1 in D3 and this one is the 1. So we will find out the input combination. We will find out the input combination, that means BCD binary combination. Okay, so we will find out the input combination corresponding to this one. So what is the input combination? The input combination is 1 0 0 0. So in ABCD form we can write this as A, B bar, C bar and D bar. Okay, so for this one we can write the input combination as A, B bar, C bar and D. Because of these two, one that is available in D3, we have mentioned the equation as D3 equals to AB bar C bar D bar plus AB bar C bar D. So to minimize this equation, we can use various methods. We can minimize it by using Boolean theorems and laws. We can also minimize it by using K-map. We can also minimize using Cohen-McCloskey method. But here I am taking a K-map to simplify this equation. Because of the four variables, I have made a truth table of 16 cell, that is 2 raised to power n cells, 2 raised to power variable cell. Here this one is 0 0, this one is 0 1, this is 1 0 and this one last one is 1 1. So here I am writing 0 0 0 1 1 0 and 1 1. So accordingly 1 0 0 0. So by using this mean term we find out its position in the cell as here 1 0 0 0 and this one 1 0 0 1. So it will be present here in the cell. So this one is the grouping of this mean term. So what we will find in the output, we will find output as D3 equals to A, B bar, and from the column we will find out C bar. We'll find column C bar. Okay, so this one is the output equation for D3. Same as we will calculate the equation for D4, D2, D1 and D0. Okay, suppose I am calculating the equation for D0 also. Okay, here I am taking a equation for D0. So the equation for D0 will be, so equation for D0 will be, first, because of this one, the input combination will be A bar, B bar, C bar, D. A bar, B bar, C bar, D. Now, because of this second one, the input combination will be A bar, B bar, C, D. A bar, B bar, C, D. Now, because of this third one, the input combination will be A bar, B, C bar, D. A bar, B, C bar, D. Same as for fourth one, the input combination will be A bar, B, C, D. A bar, B, C, D. Now, oh, okay, for this one, the input combination will be A, B bar, C bar, D. A, B bar, C bar, D. For this one, the input combination will be A, B bar, C, D. A, B bar, C, D. Plus. For this one, the input combination will be A, B, C bar, D. A, B, C bar, D. And for last one, the input combination will be A, B, C, D. A, B, C, D. So, by observing this equation, we will find out that here total 8 minterms are there. Here total 8 minterms are there. And because in this equation 4 variables are present, so to simplify this equation, we will draw. We need a K map in which 16 cells are present. So here I have made a K map. Okay, so here I am writing AB, this one is CD, 0 0 0 1 1 0 and 1 1, same as here 0 0 0 1 1 0 and 1 1. Okay, so I am writing the mean terms in this cell. So first mean term is A bar, B bar, C bar, D, that is 0 0 0 1. So what is the position? Its position will be 0 0 0 1. The second one is 0 0 1 1 here. The third one is 0 1 0 1. This one. Fourth one is 0 1 1 1. Fifth one is 1 0 0 1. Sixth one is 1 0 0 1. Sixth one is 1 0 1 1. Seventh one is 1 1 0 1. Then eighth one is 1 1 1. Okay, so these are the mean terms. These are the mean terms. When I group these all mean terms, so only one group is required for the grouping. So what is the answer in that case? We will find out. Nothing is common in the row, only D is common from the output side. Only D is common from the output side. Okay, only D is common in the output side. These D is common in the output side. So what we will get in the output? We will get output as D naught equals to D. Got it? So here I instead, wait a while. Okay, here in the truth table, this B naught is nothing but a, this one is nothing but a B, this one is nothing but a C, this one is nothing but a D. Okay, so when we find out the equation for D naught, so D naught equals to D. D naught equals to D in terms of B3. If I want to represent it in terms of B3, so what I can write it? I can write it as okay. I can write it as D naught equals to B3. Okay, so by using these methods, by using these method, we can say, by using truth table, first we have to calculate the equation, then by using kmap we need to minimize the equation, and after the minimization we will draw its logic diagram. We draw its logic diagram. This logic diagram is also known as its logical representation. The making of this logic diagram is also known as its logical representation. So, okay. So this one is the logic diagram. This one is the logic diagram. This one is the logic diagram. And how I made this logic diagram? I made this logic diagram. I made this logic diagram by using this truth table. I made this logic diagram by using I made this logic diagram by using this truth table. First, I made this truth table. After making the truth table, I find out the equation for D naught, D1, D2, D3. Okay, such as here D naught equals to B3. So here D naught equals to B3. So for its representation, first I made the input combination here B0, B1, B2, B3. These are the input combination B0, B1, B2, B3. And by using NOT gate, I have find the various wires that from that we can directly take the inputs and its complement also. Okay, so by using this expression, by using the expression that I have mentioned above, such as D naught equals to B3. So suppose this one is the D naught. So for finding the D naught, I have to connect this D naught with B3. Okay. So by using this connection, we can directly find out the equation. Okay. We can directly find out the equation. Okay. I think it is clear to all of you. Here, one thing you have to understand that this B3 is nothing but a, this one is nothing but a B, this one is nothing but a C, and this one is nothing but a T. Why I'm writing this ABCD? Because I am taking ABCD variables instead of taking B3, B2, B1 and B0. That's why in my equation I have calculated in terms of ABCD, and in truth table it is represented in terms of B3, B2, B1 and B0. Okay, so here the equation is D naught equals to D naught equals to D, that is B naught. Okay, so here, okay, okay, so here D naught equals to, here D naught equals to B naught, here D naught equals to B naught. So by using the below mentioned logic diagram, we can check that when we connect B naught directly with the D naught, so it will represent this equation. Same as for D3, same as for D3 same as for D3. D3 equals to A B bar C bar, A B bar C bar. In terms of B3, B2 and B1, we can write it as B3 B2 bar B1 bar, B3 B2 bar B1 bar. Okay, so you can check it directly from this side. You can check directly from this side. You can check it directly from this side as this D3 equals to B3 B2 bar B1 bar. Okay, so this one is all about the code conversion, in which we have converted binary code into BCD code. Thank you so much.